All right, hello. My name is Juan Romero, and this is a very, very short video, kind of just explaining what reinforcement learning is. So first, I'm going to be talking about different type of learning models. The first one I'm going to talk about is supervised learning. Just a quick overview. So essentially, this one has input data and output data that have labels. The goal of this one is that based on the labeled data we give the model, we can then feed it unlabeled data, and the model accurately classifies this new data. So for example, I feed it a bunch of pictures of apples, uh, have the model learn that this is an apple, and it doesn't really have to learn that much, right? It just has to associate. I'm literally telling the model that this image of an apple is an apple, so that later on when I give it data that's unlabeled, right, it can tell me this here is an apple. Okay. And then we have unsupervised learning. Unsupervised learning, the data has no labels. The goal of this model is to associate and group data that is similar. Okay, so for example, let's go back to that fruit example, right? So it's gonna see, I feed it input data that has image, in this case, images that have apples, bananas, and oranges. So over time, this model is gonna notice that these apples have, th- it's gonna group them. So it's gonna notice that this group of images look very similar. There's this other group of images that look pretty similar, and then so on with the oranges, right? And then it's basically gonna feed that, it's gonna give that to me, right? It's gonna give me these kind of like groups of data where it thinks that this particular group um, are really similar, so they probably belong together. This one belongs together, and then the other one belongs together. And in this case, pictures of apples are gonna be together, pictures of bananas are gonna be together, and pictures of oranges are gonna be together. Okay, so now reinforcement learning. So the data here is shown in the form of states and action. And this is a paired data. So the states is essentially the observations of the data. Okay. The actions are the decisions that the model is thinking about taking in this given state. Now the goal of reinforcement learning is to maximize rewards that it will obtain in the future. Okay. So this is where we introduce something called the reward function. Okay, so for example, in this little image that I put on the left, right, we have in this case the agent is this little kid, right? This little kid is hungry. Okay, so it has an idea. It says, "Well, I'm hungry. If I eat this burger, I'm not gonna be hungry, right?" And it's illustrated with a little hunger bar that's halfway full. If we eat that burger, we're gonna be full. Okay, so this is essentially what reinforcement is doing. Um, it receives a state, it thinks what happens if I take this action and will I get a reward from it? Okay. So now some key concepts of this is the agent. Okay. So like I said, I actually used the word in the previous slide. The agent here is the thing that's taking actions. In this particular example, the kid was the agent. In my example here, it's going to be this dog. Okay. The environment is going to be where the agent is living. Okay. And then the agent makes actions inside this environment. Now, the actions are the set of movements it can make, right? So, for example, left, right, up, down. And now we have observations. The observation is essentially the state of the environment after the action is performed. And these observations are then passed on to the agent. And then we have reward, right? We have a measurement of success or failure of action. And it's important to note that rewards can come later. And now this is important for the model to know this. So for example, in this example here, our agent here is the dog, like I said, right? Now the dog, let's say for example, a person is playing catch with a dog. Now the person is gonna throw the ball, and the dog can make the the dog has a set of actions it can make. It can either stay put, it can look at the dog, it can look at the ball, it can go for the ball, um, or like I said, just not do anything at all. So after some time, of you continuously throwing the ball and the dog not doing anything, there's a probability that the dog says, you know what, let me go take a look at what's up with this ball, right? So the dog now takes this action, it retrieves the ball, and it actually brings it back to you. Because of this, right, the dog gets a treat. Okay, so that's when we have this reward function, uh, and then the dog now realizes, wait a minute, if I go get this ball, I'm gonna get a treat, and it's essentially the concept of reinforced learning. Okay, so now, like I said before, it's important to know that the rewards can come later. Okay, because this is something that happens in real life as well, right? Now, how do we implement something like this, right? So now, just the reward function alone is essentially just uh, the summation of every reward at a given time. Okay, that's essentially the total reward. However, with future rewards, we have to prioritize a reward. We have to prioritize getting a reward now rather than later. For example, that hungry example that I gave earlier, right? We can either choose to eat the burger now, or we can choose to eat the burger tomorrow. But we're hungry now, right? At the end of the day, the reward is the actual reward itself is the same. We're eating a burger, but we have to prioritize eating the burger now, right? Because if we're hungry now, you know, we have to eat now. So then this is when we introduce something called a discounted total reward, right? Now, this we have a discounting factor. This discounting factor is a constant that is determined by the environment, and this helps us prioritize reward now over later. Okay, this helps us kind of give a lesser value to a reward that we might get later, and that's how we prioritize that. If the reward is less, if the value of the reward is less, receiving this reward later than now, well then we'll just go with a path that can get a reward now. Okay. Now Q function. A Q function, this is essentially this right here is what is doing a lot of the heavy lifting, right? So the Q function, given the current state and the current action, this Q function returns the expected total future reward the agent will receive if this particular action is taken. Now, the main goal is that the agent needs to maximize the output of this function. And so the agent needs a function called a policy function. This function is going to try to guess the best action to take at that current state. So to summarize essentially what reinforcement is this is a learning model where we get a particular state and we now have to think best what is the best course of action I can take to maximize my rewards. It's essentially what reinforcement learning is, and that is very different from supervised learning and even unsupervised learning.